It's 10. We'll start our class. Going to start our next chapter, Introduction to Trigonometry. Okay. Those who understand the formulas and remember the formulas, this chapter will be very easy. Otherwise, it will be difficult. That's how students feel every year. We'll make it easy. Don't worry. So, what we are going to study in this trigonometry is it's all about the right angle triangle, and we are going to define some functions called as trigonometric functions. And what exactly we are going to study about this for finding the height of the things and the distance. For example, if I want to find the height of the Qutub Minar, I no need to use the scale or anything to measure. If I know few basic things, so this is the Qutub Minar and this is the ground, and the man is standing at a distance from the Qutub Minar and he is looking at the top of the Qutub Minar. If I know this angle, there is an instrument to measure this much angle, then I can, and you can measure this distance from the Qutub Minar, how much distance, how far he is standing or he or she is standing from the Qutub Minar base, then you can easily measure the height of the Qutub Minar. And similarly, if I want to find from one building to another building the distance, or the, for example, if this is the ship and this is the lighthouse, you know what is the lighthouse means, which lies on the shore to show the, this is the shore, there will be a light signal for the ships. So if I want to find how far from the base the shore is, how far it is the ship is lying, these are all the things you can measure. And the third type of question is if balloon is moving at a certain height and the height is constant and moving from A to B, if I know the person is looking at the balloon here and after certain time it is moved here, I can find at what speed the balloon is moving. Okay, these are all the few examples which I can solve by using the trigonometric ratios. So before I go for the trigonometric ratios, let me insert the triangle. So what is right angle triangle? Here. If I consider any right angle triangle, we call, if this is 90 degrees here and opposite to 90 degrees, the hypotenuse, I think everybody knows that we call this as hypotenuse. So we can represent hypotenuse as h. And if I take this angle as theta, for example, here, if you want to name them, maybe this is A, then we put this as A, and let me put this as B, angle A, angle B, and this is angle C. This is the right angle triangle ABC, right angle at A. So, okay, this is hypotenuse we call. If I want to talk with respect to B, then this side, let me wait. We call this side as adjacent side, and this side AC we call it as opposite side, and this one we call as hypotenuse. Is that clear? AB is the adjacent side. I am talking with respect to angle B, because adjacent means this angle is forming with the help of AB and BC. So this side is just adjacent to an angle B. That's why we call it as this as adjacent. And this AC side is opposite to angle B. So that's why we call it as opposite side. If I want to talk with respect to angle C, then AC will be the adjacent side and be the opposite side. Okay. So these are the two things to be understand, which, and with respect to you're talking about, that correspondingly adjacent and opposite sides will be interchanged. And the hypotenuse, obviously for the right angle triangle, hypotenuse will be unique. That will remain same whether you talk with respect to angle B or whether you talk with respect to angle C. In any way it can be same. Manas is trying to join. Let him try. Okay. So we got the definition, what is the hypotenuse, what is the adjacent, and what is the opposite side. So here in this diagram, I am talking with respect to B. So this angle, sorry. So this angle we can call it as a theta. If I want to know what is, I think everybody know the symbol theta. Most of the times we use this word theta and we use that symbol. Let me show you how theta symbol look like. Uh, yeah, this is the symbol for theta. Okay, so sorry. Let me define. There are 6 trigonometric ratios. We are going to discuss all 6 trigonometric ratios. I am taking angle B as theta. Okay, so if I want to define, let me insert the equation. Okay, so that the theta sign will come easily. You can say angle theta or you can say angle B. For example, if I want to define sine B, okay, instead of theta I have taken as B, sine B. The definition of sine, actually the spelling is S-I-N-E. So we don't use E, general form, we write it as sine only. The definition of, sorry, sine is opposite side upon hypotenuse. Opposite upon hypotenuse. Or if you want to write it in terms of A and B, sorry, equals to, here opposite side is AC upon hypotenuse is BC. This is the definition of sine B. If I go for definition of cos B, cos B, if I go, definition of cos B is adjacent upon hypotenuse. If you want to write in terms of AB, ABC, then it will be AB upon BC. You want to write capital letters. AB upon BC. This is the definition of cos B. This is the second. Cos also they write it as cosine, but we don't put that. But easiest and simple way of putting, we use as cos only. Sine, cos. Next one is tan. Okay. So it will be tan B. Next, sorry. The definition of tan B will be opposite side upon adjacent. Opposite upon adjacent, or you can call it as AC, that is opposite side. AC upon adjacent is AB. AC upon AB. I request you not to remember AC upon BC, AB upon BC, or AC upon AB, because if ABC positions are interchanged, then AC upon AB won't will work for sine B. For example, in place of B, if I take A and here I put B, or maybe somewhere here I put C, then AC upon AB won't work. So better you remember opposite upon hypotenuse, adjacent upon hypotenuse, opposite upon adjacent. Now next will be, here I'll come. Next one will be cosec will be cosec B, which is equals to, now onwards the reciprocals will come. See, sine B I have taken as opposite upon hypotenuse. Now cosec will be hypotenuse upon opposite. It will be the reciprocal, hypotenuse upon opposite, or you can write it as BC upon opposite is AC. This is for cosec. Next one we left out is D. Let me insert the equation. sec B equals to, it will be the reciprocal of cos. That will be hypotenuse upon adjacent. Hypotenuse upon adjacent, that you can write as hypotenuse is BC upon adjacent is AB. Okay, that is second definition. Next we have is finally cot. Cot B equals to, let me put the equation. This is the reciprocal of tan. Tan is opposite upon adjacent. Then here you will get adjacent upon opposite, or you can put this as adjacent is AB upon opposite is AC. So these are the 6 trigonometric ratios which we have to remember the definition. And B is opposite upon adjacent, cos B is, sorry, sin B is opposite upon hypotenuse, cos B is adjacent upon hypotenuse, and B is opposite upon adjacent, cosec is hypotenuse upon opposite, sec is hypotenuse upon adjacent, and cot is adjacent upon hypotenuse. So these all definitions we have to remember, or you complete class 12 if you opt for math. Not only 12, even further studies also. Yeah, they are given sin, cos, tan, cot, sec, cosec. Okay. Now, after defining the definitions, we have the some relations. If I take, for example, let me take equation. If I define you as, yeah, let me put the fraction. If, for example, if I divide sin B upon cos B, if I divide these two ratios, what will come? Sin upon cos means I'll get opposite upon hypotenuse upon adjacent upon hypotenuse. Do you agree? So here it will come opposite upon hypotenuse, and here cos B means adjacent upon hypotenuse. Now if I simplify both of them, what you get here, both the hypotenuse, both the denominators will get cancelled, because this is also hypotenuse, this is also hypotenuse, so the values will remain same, both will get cancelled. I left out with opposite upon adjacent. But if you see opposite upon adjacent, that is the definition of tan B. Tan B is nothing but opposite upon adjacent. So I can write here as sin B upon cos B equals to B. That is first formula we have. These are all the definitions which we discussed here. This everything is a definition. The first formula is sin B upon cos B equals to tan B. So wherever I see sin upon cos, I can put it as tan. Or wherever I see tan, if I want, I can replace it as sin upon cos. See, these relations I use mostly. Now, obviously, next ratio I'll think of is cos upon sin. Initially I have taken sin upon cos. I'll go for cos upon sin. So you will get cos B upon sin B. If I take the reciprocals, then what do you get here is, first I will get adjacent upon hypotenuse. That is the definition of cos. Then sin means opposite upon hypotenuse. Hypotenuse. Now here also your hypotenuse will get cancelled. Then you left out with adjacent upon opposite. Adjacent upon opposite. Now I think this is the definition of cot, adjacent upon hypotenuse. Cot B is adjacent upon hypotenuse. So here also I have adjacent upon hypotenuse. So here I can put this as B. So cos upon sin is cot. Sine upon cos is tan. So sine upon cos B is the reciprocal of cos upon sine B, or I can say vice versa. Cos upon sine B is the reciprocal of sine upon cos B. So can I conclude tan B is the reciprocal of cot B, or cot B is the reciprocal of tan B? Can we say that? Yeah, you are given the answers. So can we say tan is the reciprocal of cot and cot is the reciprocal of sine? Say yes or no? Yes. This is the second formula. Cos upon sine is cot. Sine upon cos is tan. Now we are going to the third formula, which is reciprocal of one is the reciprocal of other. Tan B is equals to 1 upon cot B. Tan B equals to 1 upon cot B, or you can put cot B equals to 1 upon tan B. Both the ways it is. If you want, let me write. Or let cot B is equals to 1 upon tan B. Both the ways it is okay. Now similarly, as we discussed, sine is the reciprocal of cosec. You can see here, sine is opposite upon hypotenuse. Cosec is hypotenuse upon opposite. So this is the reciprocal. So next formula I derive here is, let me insert here, sine B is equals to 1 upon cosec B, or cosec B equals to 1 upon sine B. So both the ways you can write. Now similarly you can derive the last formula, which is cos B is equals to 1 upon sec B, or sec B equals to 1 upon cos B. So these are the few formulas which you need to remember. Sine upon cos is tan, cos upon sine is cot, tan is the reciprocal of cot, or cot is the reciprocal of tan, sine is the reciprocal of cosec, cosec is the reciprocal of sine, and cos is the reciprocal of sec, and sec is the reciprocal of cos. Do you want me to write other formulas also? Let me put once. Then I'll get sec B equals to 1 upon uh, cos B. Here also, if you want, let me add this formula also. Cosec B is equals to 1 upon sin B. So these formulas are clear, how they are related to one another, why they are related, how they are related. Okay. So I think we have done these angles. We have given the definitions. Just read this, all this theoretical, okay? Next. We'll discuss few examples. Okay. Now example 1, given tan A equals to 4 by 3. So let's take few examples based on this concept. What is given is tan A equals to 4 upon 3. You have to find all other trigonometric ratios. I think that is the question. Find the other trigonometric ratios of angle A. So what you do is this type of one. These are the 1 mark questions. So what you do is immediately you draw the diagram, which is right angle triangle. Just make one right angle triangle of any size. What is given here? Tan A is given. So if tan A is given, one more thing here, let me clarify. Your trigonometric functions can be defined at B or at C, not at A. If I want to find here sine A, So I cannot define what is opposite side, what is adjacent sides, because if I take A angle here, AB is also adjacent, even AC is also adjacent, because this 90 degrees formed by with AB and AC. So that's why whenever they say here they are given tan A, that means A is not 90 degrees. We'll come to that. If A is 90 degrees, how to derive, we'll discuss later on, maybe after 2-3 classes. So tan A is given. So here I will put A angle. So this is my angle A. Okay. If this is angle A, what is the tan definition we discussed? Tan is opposite upon adjacent. This is the tan definition, opposite upon adjacent. So that means your opposite side value is 4. Okay. Opposite value is 4 and adjacent value is 3. Which I is hiding. Adjacent value is 3. So if you want, you can take this triangle. Can you find the hypotenuse by using the Pythagoras theorem? Yes or no? Yes, we can find. So I think everybody knows how to find the Pythagoras theorem. So what is the hypotenuse value? Can you tell me what could be the hypotenuse value? It is the Pythagoras triplets. Yes, it is 5. So your hypotenuse value is 10. Its hypotenuse value is 5. Now I can go for, first of all, let me take here. Yeah. Sine A. What is the definition of sine? Sine A is, definition is opposite upon hypotenuse. Opposite is 4 and hypotenuse 5. Is done. Then I'll go for cos A. What is the cos definition? Adjacent upon hypotenuse. Adjacent is 3. Hypotenuse is 5. Is done. Cos is done. Tan is already given. Cosec A. Cosec A is the definition of cosec, hypotenuse upon opposite. Hypotenuse is 5, opposite is 4. Next I have sec A equals to, there are two ways to find cosec and sec values. One, you can go by formula or definition. Second, you can go by the formula. Sec is the reciprocal of cos. Cos is 3 by 5. So sec will be, next finally, cot A equals to, cot is the reciprocal of tan. Tan is 4 by 3. So cot will be 3 by 4. This is the reciprocal. So this way also we can solve it. Is that clear for everyone? Yeah. Actually, you are giving the answers. So only thing is these questions are easy when I remember the definitions. If you remember all these definitions and all these relations between each trigonometric function, sine upon cos, cos upon sine, tan is the reciprocal of cot, sine is the reciprocal of cosec, or cosec is the reciprocal of sec, and vice versa. If you remember all these formulas, then it is easy. Okay. See, in the question, they are taken as k also, 4k, 5k, 3k, because 4 by 3, which will be same as another value also. Maybe I can take it as 8 upon 6 also. It can be same as 12 upon 9 also. Or maybe it can be same as 16 upon 12 also. All these ratios will give me the simplest form is 4 by 3. So that's why they put the k. Whether you put the k or not, it doesn't make the difference of your answers. Here what you get is 4k upon 5k. Kk will get cancelled, still it will remain 4 by 5 only. Here also maybe you will get 3k upon 4k. Kk will get cancelled, still it will be 3 by 4. So it's okay whether you write k or not. It doesn't make any difference in the exam. Next one is We'll come to the next example. For example, yeah, uh, example 3. Consider a right angle triangle ACB. So here ACB is a right angle triangle. Right angle at C. So 90 degrees are taken at C, in which AB is 29. So here AB value is given as 29. BC value is 21. So BC value is also 21. And angle ABC equals to theta. That means theta is here. Determine the values of sine square theta plus cos square theta, or cos square theta plus sine square theta. Another is cos square theta minus sine square theta. So to find sine and cos values, at least to find sine value, I need AC value. So how do I find AC value? By using the Pythagoras theorem. So if you want, let me take the example. This is example. So let me insert the diagram. Where is the right angle triangle? Here is the right angle triangle. So what is the things are given? A is here. I think C is here. And B is here. Is that right? Yeah, B is here. And this value is given as 21. And hypotenuse value is given as 20. There it is. Hypotenuse value is given as 29. So I have to apply the Pythagoras theorem. As per the Pythagoras theorem, I think everybody remember. Pythagoras theorem says that hypotenuse square, that is AB square, is equals to AC square plus BC square. AC square plus BC square. Now AB value is given as 29. So it will be 29 square is equals to AC square is unknown. So I will keep AC square. Yes, I am solving those who have the doubt how to use the Pythagoras theorem. For them, I am solving it once. Plus BC value is 21. So it will be 21 square. Those who already knew, they can try in their notebook now itself and give the final answer. So 29 square will be, any idea? 30 square is 900. I think 29 is 861. 841. 841 is equals to AC square. So let me copy this AC square. It is coming multiple times. AC square plus 21 square is 441. So it is going for exponential. Plus this is 441. Next step is, I can bring 441 to the right hand side. It will be 841. 841 minus 441 is equals to AC square. Then 841 minus 441 is 400 is equals to AC square. Now what happens is, if I want to remove the square root, AC is do square root on both sides. Under root 400 is 20 equals to AC. So AC value I got it as 20. 20. Now we have opposite value as 20. If you want, you can write here. Okay. Opposite value, if you want to mention, opposite value is 20. Adjacent value is 21. And hypotenuse value is 29. Now you apply what you want, sine theta value and cos theta value. So how do you find sine theta value? Here they are given theta is at, and ABC is theta. Okay. So I think I have to insert the equation because I need the theta symbol. Sine theta. So theta is at B. So it is nothing but sine B only. Sine B equals to opposite is 20 upon hypotenuse is 29. This is sine value. Now we go for cos theta value. What is the cos definition? Adjacent upon hypotenuse. So your adjacent value is 21 upon hypotenuse value is 29. Now what is the first question they are given is, let me put the first question here. Let me see if anybody has given the answers. Is sine square theta plus cos square theta. So let me insert sine square theta here. Sine square theta plus cos square theta. So what do you mean by sine square theta? We studied only sine theta, but if this is given as sine square theta is nothing but sine theta whole square. So sine theta whole square means, what is sine theta value we have? Sine theta value we got it as 20 upon 29 whole square. Square theta is nothing but sine theta whole square only, so nothing to bother about that one. About cos square theta is cos theta whole square. So cos theta value I got it as 21 upon 29 whole square. So now this step I have to simplify further. How do I simplify? Is equals to, let me put the equation here. Now 20 square is 400. 29 square is 841. This I got it for the first fraction. Second fraction is 21 square is 441 upon 29 square is 841, which is equals to, if I take the LCM, here LCM is going to be 841. So numerator what you get, 400 plus 441, which is nothing but again 841. So 841 upon 841 is 1. Sin square theta plus cos square theta value is 1. Now what is the second question answer? Second question is given as sin square theta minus cos square theta, right? Let's see the second question. Sin square theta minus cos square theta. Sin square theta minus cos square theta. Let me copy this. Till here I'll copy. Till here I'll copy. This is sin square theta minus cos square theta. That is, here minus sign will come, 20 upon 29 whole square minus 21 upon 29 whole square. So next step we are going to simplify. Same will come, I think of 400 upon 441 instead of plus, minus sign will come. So here minus will come, which is equals to, now what do you get? LCM, again I'll go for the LCM. So LCM is going to be 841 only. 841. In the numerator you'll get 400 minus 441, which is minus 41. So this is going to be our answer. Is this example clear for everyone? Or anyone has doubt? The second question is cos square theta minus sin square theta. Sorry, I think I kept it answer. That's why I got negative value. If it is cos square minus sin square, then 441 minus 400, that is 41 upon 841. That will come. Is it clear? Or anyone has doubt? Yeah, the Divansh has given the answer. Yes, everybody and very good. Mahima said no, Arnav said no. Not understood or no doubt? Mahima, understood or not? No doubt, okay. So we'll move to the next example, if any is there. So I am solving only those questions where I have to find the value. Other questions we'll discuss in the next class. Now if I go to 8.1 exercise, and right angle triangle ABC, right angle at B, AB is given, BC is given. You have to find AC value by using the Pythagoras theorem. After finding AC value, you have to find sine A cos A, then sine C cos C. What do you mean by these questions? For example, if I take this diagram, uh, A, A here, B here. This is the diagram of the given question, right angle triangle and right angle at B. You have to find sine A cos A. When I take A, this is my opposite that I already discussed. This will be adjacent and this will be opposite. So sine A cos A values I'll find out. Now when I comes to sine C cos C, my angle will move to from A to C. This will be my angle now. When I take C, so this will become opposite and this will become adjacent. Okay. The length AB value, BC value, AC value will remain same. But only thing is the position of the words opposite and adjacent will interchange if I move from A to C. I am not going to change the length of the triangle or height of the triangle or the hypotenuse value. Those values will remain same, but this opposite sides will become here and adjacent will become here. Can you solve that one or you want me to solve it? Yes, student? Can you try? No, yes, no, no. We'll solve. Good. So like this, I think second question also you can try. Sine A is given. Sine means opposite is given. Opposite is 3. Hypotenuse is 4. Find the adjacent. Can anyone tell me adjacent? What will be the adjacent side here? Can you guess what will be the adjacent side? Is it 5? Anyone is thinking that adjacent is 5? Yeah, I got the answer. See, be careful, huh? Here sine is given 3, 4. So sine value means opposite is 3, hypotenuse is 4. So if you are thinking that adjacent is 5, that means your adjacent side is greater than the hypotenuse. Is it possible in the right angle triangle? So don't think 3, 4, 5 will always be correct. Here hypotenuse is 4, your adjacents will be, AB value will be less than 4. It will be under root 16 minus 9. That is under root 7. So AB value will come under root 7. Okay. So please be careful. Is that clear? Don't write blindly, it is 5. Yes, root 7. So I asked the question, I know you give me the answer 5. Now question number 4, given 15 cot A equals to 8, then cot A equals to 8 upon 15. What is the definition of cot? Definition of cot is adjacent upon hypotenuse. So adjacent is given as 8, opposite is given as 15. So you have to find the hypotenuse. After finding the hypotenuse, you have to find sine A and sec A. Fifth question also you can try it out. Sixth question you leave it. Sixth question you leave it. Seventh and eighth you try it out. Even ninth also you can try it out. So till ninth question, other than sixth question, I am giving as homework. Try it out. If you are not getting, next class we'll discuss. For example, seventh question if I give you, Seventh is cot upon 7, cot theta is 7 upon 8. So adjacent is 7, opposite is 8. You get the hypotenuse. After getting the hypotenuse, you find sine value and cos value and substitute here. 1 plus sine value into 1 minus sine value upon 1 plus cos value into 1 minus cos value. Then you take the LCM and simplify. Okay. Here also cot A is given as 4 by 3. 3 cot A equals to 4. Then cot A will be 4 by 3. If cot is 4 by 3, then what is tan value? If cot is 4 by 3, then tan value will be 3 by 4. It is the reciprocal, right? So once you got tan value is 3 by 4, then you substitute here 1 minus 3 by 4 whole square upon 1 plus 3 by 4 whole square. So that means you will get, I think, 1 minus 9 upon 16 upon 1 plus 9 upon 16. Take the LCM, then simplify. You try it out till question number 9. Then we'll discuss in the next class. If any questions you have doubt or not able to get it, then you can ask me. Okay. Bye bye.